Hello everyone, welcome to AWS and Linux Foundation course. Today the agenda is to continue our discussion on Linux permissions. In the last lecture, we have talked about Linux permissions in terms of how the file permissions are impacted and the sudo permissions in granting the special privileged access to the privileged commands to be executed as like a ordinary user, right? So with the help of the sudo as a prefix to your command, and we have seen read, write, execution permission for a file. So today the scope is to discuss about the permissions on the directories, and we will be discussing about the Linux user groups, right? And then we will talk about the configuration and the log files as the time permits. Okay. So let's get into the discussion, guys. Okay, so I just need one Linux instance to continue our permission section, right? So in my AWS management console, I have the EC2 instance one in running state. Let me take this public IP and let me logging into the instance using my putty using the saved session. Let me give the correct IP address over there and let me logging into this instance using my default username ec2-user, and let me clear the screen. Now at least you know that sudo su hyphen is a command that will be taking me to the super user account. Well, so I think let me clarify one thing that by default, how come the EC2 hyphen user is able to switch to the root, right? So as I said, to run any command with the sudo as a prefix, that command permission must be granted, right, in the sudo's configuration file, right? So if you go to vi sudo and hit enter, right, you do not see anywhere mentioned that the ec2-user is having the permission to run that specific command, but still how the user is able to run the command to go to the root, right? You see here that if you need to give the privileged access to the specific individual user, then you need to add a entry like this, right? And we have seen how to add a specific entry to the specific user in last lecture. And below you can see the syntax that if you would like to give the permission to the group of people to run a specific privileged command, then this is the syntax case, right? So in the commands section, you see ALL, that means I would like to give all the commands access to be executed as like a super user. That is what does it mean, not a specific command. And you see that if you would like to give the permission to the group of people, right? This is the syntax. We need to give this the percentage symbol, then the group name, and follow the syntax case. That means any user who are part of this wheel group is having the complete access to run any commands using the sudo. That is what it is, right? In Linux machines, wheel is the default group that is available, and the wheel group is called as a super group. Any user who is part of the wheel group is having the complete access on the system with the help of the sudo permissions because of the syntax case, right? Being said that, if I now come out from this VI editor, right? Now, if I see ec2-user using the id command, you observe that ec2-user command, sorry, user ec2-user is actually part of the wheel group. You see, of course, EC2-user is part of many groups that you see in the list, but the precisely wheel is the group that is part of, right? As this user is part of the wheel group and the wheel group is already added in the sudo configuration file granting the permission to run all the commands, my EC2-user is able to run sudo su- command to go to the root case. That's what is the logic behind. By default, when you launch a EC2 instance, the AWS is provisioning a operating system by keeping your EC2-user in the wheel group by default. So that's the reason you are able to go to the root. I hope this puzzle is now solved, how a EC2-user is able to execute a command to go to the super user account, because you are not doing any modification that time, right? You are creating a new user account, new groups, and you are customizing them by adding the entry in the etc sudo file. That's how your customization. But the default EC2 is already getting that root access because the user is already part of the wheel group, right? Those are the default groups that are already available in the Linux system. Good. Now, going back to this slide, this is where we have talked about that the file permissions read, write, execute, and the meaning of a read, write, execution for a file, and how a owner of the file can grant a permission to the owner and to the group and to the others. And we have seen how to create a group, adding the users to the group and other scenarios, right? Good. Now the scope is to discuss about the directory permissions, guys, right? So let me go ahead and start creating a users again on my system, because this is a newly launched EC2 instance. The previously created these users are not available now, right? So let me create these users again so that we can replicate the same behavior now, right? So as a root account, I'm just creating the required users. I'm just creating the same users, right? As per the previous discussion, right? Let's say user add AR user, right? I'm just creating some multiple user accounts here, right? Good. Now let me logging into the server, right? In a duplicate session. I wanted to logging into these user accounts, guys, in order to show you how exactly the user permissions are impacted, right? So ideally, you cannot logging into these users directly. As of now, I need to go to EC2-user, then you log into the root. From the root, you just need to switch to the specific ordinary user that you would like to work on. I can show you how to logging into the server directly from your ordinary user like a PR in a later session. As of now, by default, your EC2 instance is not allowing you to logging directly by supplying your own credential. Hence the reason I'm going to the root and then I'm switching to that specific user account by using the switch user command. And here I logged in as a PR user. Good. Now let me go to the one more session, and here I would like to log in as another user, right? So I will go to root. I'll switch to the user called, let's say, AR, right? So here in the current terminal, I logged in as PR user, and definitely I will be in the home directory. And let me see, the list is empty. Now let me create a directory, guys. mkdir, let's say dir1. Let me do ls-l, right? Now you see that the directory is created. Even the directory is having the same kind of metadata attributes like a file. So in this output, the starting character D refers that this is a directory, and later whatever the base permissions that you see is again the starting three positions are applicable to the owner. The next three positions are applicable to the group of the directory. The next three permissions are applicable to the others. As usual, the highlighted column is talking about the owner of the directory, and the other section is calling about the group of the directory and the recently accessed timestamp. So The properties are same like a file only, but there is a difference in terms of what does it mean by a read write execution for a directory, right? So if I go back to this presentation, right? So let's see for a directory. Yes. So read permission to the directory in the sense what? What is that you are reading in a directory? If it is a file, you are reading the content of the file, right? If you are reading a directory is mean that you can run a ls command to see the list of the files that are in that specific directory. Write permission to the directory is mean that you can run a touch command or rm command or maybe a move command, correct? That means you can create a file or you can delete a file from the directory if you are having a write permission to that specific directory. The execute permission to the directory is mean that you can run a cd command to go inside a directory. That's how the difference between the file and the directory in terms of read, write, and X permissions, guys. Now, with this information, if I go to this terminal, right, if I ask you what permissions that are applicable to this directory for a currently logged in user PR, the currently logged in user is the owner of the directory, right? The owner is having read, write, and X permission. That means the currently logged in user can go inside a directory by executing a directory using cd command because the X permission is already there, can run ls command because the read permission is there to see the list inside a directory, right? And even can run a touch command to create a file inside a dir1 directory because of the owner is having a write permission as well, guys. Good. Now let's say just to understand how these permissions are working, right? Let me go to a another terminal, right? So here actually the AR user logged into the system and he is actually navigating to the PR home directory, and you see the AR user is actually trying to navigate to slash home slash PR directory and it is throwing the error that the permission is denied. How should I be understanding this case, right? The current user, the currently logged in user is trying to go to this directory. And when it says permission denied, which permission is not granted here, guys? Slash home slash PR is the directory, right? Right? If the user is not able to do a cd to that directory, is mean that that directory is not having a X permission to this user. Let me verify that, right? So I can run ls command. Let's say ls minus l. I wanted to know the slash pr directory. I mean to say slash home slash pr directory permissions. Let me run this command. You see, you are not even having a list permission to see the list of the files in the pr in the slash home slash pr. That means you don't have a list permission too. So the AR user is not able to do anything on the PR home directory, right? At end of the day, though this is a another user home directory that is just a directory in the system, right? Usually any user can navigate to any location provided you if you have a proper permissions. What I do, let me come back to my PR user and let me verify those permissions here, right? So let's say ls minus l, I wanted to know slash home slash pr user permissions. What you are getting, guys, when you run ls minus l, my requirement is to see the directory permission. Which directory? PR is the directory name which is under the home directory, which is under the root, right? I wanted to know the PR directory permissions, but usually when you run ls-l flag, it is giving the list of the subdirectories and the subfiles. But I'm not interested on the childs, right? I'm interested on the directory itself. How do I get this directory metadata information, guys? Either you run the ls-l command on the slash home, which is the parent. That way, under the slash home, what child directories are there, all those directories are listed here. Then you will get to see that PR directory is there, and this directory is currently having read write X permission only to the PR user who is the owner. We can get to see here that all the users home directories are actually created in the slash home only, and each directory is a home directory for a specific user, and that user is the owner and the only owner having access. That means by default only the owner of the directory is having a permission to their home directory, no one else. That is the default behavior only. And if you want, yes, you can do the changes anytime you as a owner of your directory, right? That's one thing. The second command that I wanted to show you, rather you running the ls-l on the parent directory, if you wanted to see the details about the directory itself, you can run a command called ls-l and you give one more flag called d for directory. That means I am not looking for the childs of this directory. I wanted to see the directory itself. To see the difference between L flag and LD flag, guys, right? In the L flag, it is actually showing the list inside, but in the D flag, it is actually showing the directory itself. That's how we can see that currently this slash home slash PR directory is owned by a PR user and only the owner having an access, no one else. That is the reason in the another terminal, if a AR user logged into the server, he is trying to access the PR user home directory. He is not able to go inside, not able to see the list, and obviously cannot write a file as well because the permissions are not granted. Now the question, let me come back here. Currently, the PR user logged into the server, he actually created a dir1. Inside the dir1, he created a file. Of course, this user is having a permission because this is their home directory. The home directory owner is yours, and you can do whatever, right? So now let's say the other user would like to go to this location. So let me try that from the AR account, right? So here the AR user is trying to go inside a dir1, guys. So if he need to execute and go to this directory, he should be having a permission to go inside a root, permission to go inside a home, permission to go inside a PR directory, permission to go inside a dir1 as well. Agree with me? That means this is a navigation structure, right? You cannot go, I mean to say, though you are mentioning the absolute path of the directory to where you would like to go, if you have a permission to all these different levels, then only you can go inside a directory or else no. Let's say here the user is not able to go inside the dir1, is mean that the permission is not granted only to this directory, may or may not be. Sometimes maybe this user have a permission to the dir1 but may not be having a permission to the PR directory, may not be having a permission to the home directory. So all the parent directories you need to verify whether the user has a permission or not to enter it into. Think of like if you have multiple uh, windows that we need to go step in and accessing the nested windows, right? Obviously you should be having the all level of access. We cannot go to the bottom line window directly, right? Something like this. Well, now let me fix this issue. right? Let's say this particular directory, let's say /home/pr, right? So this particular directory is owned by the PR user, and currently I logged in as PR user. And as I said, the owner can change the permission of a file or directory. So let me grant a permission here. I would like to give the 7 permission to the owner. I would like to give the 6 permission to the group people. I would like to give the, let's say, 4 permission to the others on a directory called /home/pr. That is how I can change the permission of a directory. You see now I got 7, 6, 4 permission to my directory. So changing the permission is pretty much same like a file or a directory, but only the meaning of effectiveness of read and write and execution will be differ comparing to the file and to the directory. Good. Now let me verify this, guys. I would like to go back to the other terminal, and I would like to know what permissions that the user has on this /home/pr directory, right? So how do I know that the currently logged in user has what permission on the directory? Step number 1, you verify who currently logged in. Step number 2, you verify what permissions are applied on the directory. Step number 3, you verify the current logged in user is part of which group. Now you decide, guys, right? So is he owner of the directory? No. The owner of the directory is PR. The currently logged in user is AR. Definitely these owner permissions are not applicable to me. The second check, the directory is in the group called PR, whereas my currently logged in user is not part of the same group. So definitely the group permissions are not applicable. Yes, obviously, if you wanted to change the group to whatever you want, yes, you can easily change by using the same chgrp command, but as of now, let it be. Now, what permissions will be applicable to this user, guys? This user is considered as others. Others are having a read permission to read a content inside a directory. Can we verify that? I wanted to see the list of the files and directories inside a PR directory, and let me verify that. You still see that the permission denied error with a junk data. And you may be asking now, as per this concept, the AR user should be having a read permission to the directory. Reading a directory is mean that should be able to run a ls command to see the list inside a directory, but still why the permission is denied? Because if you would like to see the list inside a directory, first you need to go inside a directory, right? Do you have a permission to go inside a directory? No. Without you going inside a directory, how will you be able to see the list of the files and directories? Correct? That means though you have a read permission, still that is not enough for me. You should be having a permission to go inside a directory, and then only you should be having the access to the read. Technically, though you are not running the cd command, when you try to do ls command to see the list, indirectly it has to go inside a directory and has to list the files, right? Because you do not have a x permission to go inside a directory, it is not able to list them, though theoretically you have a read permission to the directory. From this discussion, can I say that for a directory, the execution permission is mandatory. After you are having the X permission to go inside a directory, then you think of whether you need a read permission or a write permission. Agree with me? Without a CD permission, without a execute permission, though I give you the read and write, will you be able to list and create? No, because first you should be able to enter into the directory, then only whether you can read it or can write it, right? That is the technical feasibility. So let me go and fix this permission from other terminal, right? Because only the owner can change the permission, no one else, right? That's the reason I'm coming back to the other terminal where the owner has logged in to change the permissions of this directory. So at this time, this directory is having 764 permissions. Let me do the change. Chmod 765, let's say 755 slash home slash pr ls minus ld slash home slash pr user. Now what permissions are there, guys? This directory is having 755. That means the owner can have read write x, the group can have read and x, the others can have read and x. So you see that the X permission is granted for everyone here because that is a mandatory permission to be granted if you would like to give either a read or a write. Now let me test the permission from the other user. As usual, first I am checking the permissions of my directory. Then I am checking who currently logged into the server. Then I am checking the groups that are added to this user. Now let me do the calculation. Is this current logged in user is the owner of the directory? No. Is he part of the same group? No. Then he become the others. The others are having read and X permission. You see now? ls minus l slash home slash peer. I am able to see the list inside a directory because I am having a read permission, and I can go inside a directory because I am having a execution permission called X case. So inside a slash home slash pr directory, can I start creating a files? Can I start creating any files? No. Why? You have only to go inside a directory and can only read the files, in the sense read the list of the files and directories. You do not have a write permission, right? Without having a write permission, you don't have a permission to create or delete the existing one. That's what I'm proving here, guys. Good. Let me clear the screen. Now, based on this discussion, what this user can do on dir1, same thing. The currently logged in user will become the others. So this user can also go inside the dir1, can read the list, but he cannot write any files because the w permission is not there. Let me give more power to this. From the PR user who is the owner of this directory, I would like to change the permission just to see what is the effectiveness of the 777 permission. Now let me go back to the other user because owner can change the permissions anytime, right? As and when he feel good. Now what permission the currently logged in user can get it? 7. That means read, write, execute. So this user can go inside a directory because the X permission is there, can see the list because the read permission is there, and can run a touch command as well to create a file because the write permission is granted, guys. Good. Now let me back here and let me prepare one simple scenario, right? I'm just preparing one simple scenario here. The currently a PR user logged into the server, he is actually creating a file there. Let's say a F2 file. He don't want to give any permission to this F2 file, and he is simply changing the permissions to the F2 because he is the owner of the file. Now F2 file, if you look into the permissions, nothing is there. Let me switch to the AR user just to see what is the impact of these permissions. He currently inside this directory and looking into the list of the files and directories. Now the question here is the AR user who currently logged into this system, can he delete a F2 file or not? I would like to know whether do I have a permission to delete a F2 file or not. How do we do the validation? So if I am planning to see whether I can delete a file or not, should I be considering about the file permission or should I be considering about the parent directory of the file permission? Correct. So deleting a file or creating a file are the right permissions of the directory, not a file, right? So I should not be worrying about the file permissions whether I am when I am trying to delete a file. So though I don't have a permission to the F2 file, still I can delete this file because I need to worry about only the directory permissions. This F2 file is currently in the /home/pr directory. For this directory, I have the read, write, execution permission. Because the write permission is there on this directory, I can create or delete a files inside the directory. That way I can delete a file, guys, not a issue. You see now the file is deleted. This scenario just to explain that if you are trying to read a file, write a content to the file, execute a file, then you need to look at the file permission. When you would like to create a file, delete a file, see the list of files and directories in a directory, then you always look at the permissions of a parent directory. Hope this is clear. Let me back to here. Now let's say I would like to run touch/f3 f4 as an example. Now I see I'm getting a permission denied error. How will you be understanding this output, guys? So what does it mean by this error? The currently logged in user is actually trying to create a F4 file in the slash directory. Possibly you do not have a write permission on the slash directory. How will you do verify that? ls-ld and let me check the permissions of the directory, right? You see now the slash directory is having these permissions. The currently logged in user is becoming others. The others are having only read and X permission. So you cannot create a file inside a slash, but you can go inside a slash because you have a X permission. You can run ls command because you have a read permission, but you cannot create a file inside the slash, and only the owner of the directory can grant or remove the permission to any other users, guys. Hope this is good. So now onwards, when you are trying to create, delete a file anywhere in your system, if you are getting an error, look at your parent directory permission, whether do you have a read, write or X permission to that specific directory. If you don't have a permission, either the owner or the root user has to provide a permission by running the chmod command to change it. Well, as of now, let me go back to my home directory again to prepare some more scenarios, right? Usually, by default, when you create a file or a directory, you are getting some default permissions, right? Let's say I'll show you something. I'm creating a F2 file. You see, the moment when you create a F2 file, by default, the owner is assigned, the one who actually created. By default, the group is assigned. By default, the group name will be the same as your username. That's a default nature in the Linux. And I'm very much curious about these permissions. How it is decided that the file should be created with 664 permission. You get me? My question is why and how these default permissions are applied to the file, because at the time of me created a file, I did not tell that the file has to be created with which base permission. It's automatically taken some default base permissions here. Same way, when you are creating a directory, even the directory also created with some set of default base permissions. So I'm trying to solve a puzzle here, how these default permissions are applied by the system automatically. That is where we need to understand what are the default set of permissions, and we'll talk about a concept called UMASK. From the concept wise, right, the file permissions are 0666 and the directory permissions are 0777. These are the default permission for a file and directory, guys. That means ideally when you create a file or a directory, the file should have 0666, the directory should have 0777. That is the default nature of by design. Now you can manipulate those default permissions however you like it with the help of a UMASK value. What is UMASK? UMASK is mean that the user mask, right? Let's see what is the current UMASK value that is defined at your server level. You can run a command called UMASK just to see what is the UMASK value that is currently defined, and you can see that 0002 is the UMASK value. How we need to calculate is from the default base permissions, right, 0666, you just minus the UMASK value, then whatever the output that you get it, those are the default base permissions for a file. Help me guys, what will be the output once you minus this UMASK value from the base permission 666? It will be 664. So that means whenever a user is creating a file, by default the files will be created with a permission called 664. That is the standard. And how that calculation? The design says the file should have 666. The UMASK is applied there and it is subtracting that UMASK value. Then the result will be applied as a set default permission to the file. The same way, the same UMASK value will be subtracted from your directories as well. Then after the UMASK the subtraction, the result will be applied as a default permission to your directories. It will be 775. Let me compare that. If I go here, when I create a file, I'm getting by default 664. When I'm creating a directory, I'm getting the default 775. Yes, that's what it is, guys. That means can I use this statement? UMASK is the value that is impacting, that is deciding what should be your default permission when you create a file or a directory. Once the file or directory is created with some default, then yes, you can change the permissions by running the chmod command, you as a owner, not a problem. But I'm just worrying about how these defaults are coming in with the help of the UMASK value. There is some default UMASK value that is already applied to the system level, but you can change the UMASK value anytime that you like it. Let's say I wanted to change the UMASK value to 0222, for example. You see, I have done the change to my UMASK value using this particular command. Now tell me guys, if I create a file, what should be the file permissions? You see, I have created a F4 file, and I'm getting 444 permission. Why? The default permissions are 666, right? In 666, I actually need to subtract my UMASK value, which is 222, and the result will be 444. And that's where you can see that the file is actually created by default with 444 permission because you made a change to your UMASK value. That means for your account, how you are expecting the default permission to be for your file and directory, you adjust your UMASK value accordingly so that the default set will become. Later, you decide how you wanted to change your permissions using chmod command. Now, let's say I wanted to change the UMASK value to cover one more scenario. Let's say 223 is my UMASK value. Now, if I create a file, now what should be the permissions of the F6 file, guys? Let me do a simple calculation here. From 666, I really wanted to subtract 223 and the output will be 443, correct? That means read permission, read permission and write plus execution permission, 3 means correct. So let me see if I have got the same here. I created a F6 file here, and you look at the F6 file and look at the default permission. I have got 444. There is no 3 permission here. Surprising, right? But based on the calculation of the UMASK, I am expecting 443, but I got only 444. The 3 is not applied there. Why so? The 3 means what, guys? 3 means you need to have a write permission and a X permission, right? The X permission is little dangerous permission to the file. Why? If there is a X permission to the file, right, the file can be a executable, right, and the users can start putting some script inside a file and can start executing the scripts, which is like dangerous. Also, the X permission is not required for all the files. Do I need a X permission for a regular files? No. Only the script files would need a X permission, right? Keeping that in mind, UMASK will not be a good calculation when it comes to the X permission to the file by default. The X permission will never come as default to the files, and that time it automatically adjusts the permission without having a X permission. That is the reason when you take the UMASK as 223, you are not getting that 3 permission there. Rather, it is actually going to a random 4 permission, guys. I'm explaining the reason why the 223 UMASK is not giving you the right default permission, because X permission cannot be given to the files by default, which is dangerous and not required as well for all the files if you are keeping any regular content inside a file. Make sense? So this is the only reason why this number will not be accurate. The rest everywhere, yes, the calculation will work and it will decide what should be the default permissions of the file. The same thing will be applicable to the directory as well, guys, right? When you are creating a directory, you see the directory permissions are adjusted based on the UMASK value, but the default directory permissions are 777. Let's say 777. The current UMASK value is 223. The result will be 554. Correct? Now you see your DAR 6, you got 554. That is how the UMASK is impacted here to decide the default permissions of your file and directory. You can change the UMASK by running the command called UMASK and give the value, whichever the value that you like it based on the requirement, and hit enter. Now you verify. If you are changing the UMASK value using this UMASK command, these changes are temporary. In the sense, once the user is logged out and you log in back again, then your UMASK will go back to your default value. The way how I have done the change of your UMASK value, that is a temporary, that is applicable only to the current specific login session. Once you log out and log in, your UMASK value is resetting to your default value again. Good to know. But then how should I be giving the UMASK value permanently so that my UMASK value always will be the same though the user will log out and log in back, correct? In the user's home directory, if you look into ls-l, by default the ls-l will give you the files and directory list. But if you give ls-l a, I'm just showing one more extra flag now. A flag is to list the hidden files also. In the Linux, any file name that start with a dot is called as a hidden file. Those hidden files will not be appearing by default with your L flag. If you would like to see the hidden files, then you need to give the A flag, guys. Any user's home directory by default will be having these hidden files. These hidden files are actually customizing your user account. Let's say there is a hidden file called .bashrc. This hidden file can have some settings, scripts, commands that needs to be executed every time when the user logging into the account. I'll show you what does it mean. I will just open this .bashrc hidden file which is available in the user's home directory, which has already some script in place. I'm not worrying about that, right? So just go to the bottom of the file and just run umask, let's say 0222, and save the file. I'm adding my umask settings in the .bashrc file available in my home directory, right? You log out. When you log in back to your user account again, now you see what is your umask value, 0222. That's how we need to set your umask value as a permanent to your user account by adding those right into a .bashrc file. You can add this to the .bashrc file, or you can add this to the .bash_profile file. Not a worry, both will be working for you. If you ask me what are these bash profile and bashrc files, these files are actually customizing your user account. Sometimes I'm expecting some commands should be executed automatically when I logging into my server. Let me show you a few more details. When I log into my server, immediately I should be knowing what is the current date. I wanted to know the current calendar. I'm just showing these are as an example. But any command that you are expecting to be executed automatically when the user login, then those commands can be kept in the .bashrc file. Then you see the difference. I'm just logging in. You see, the moment when you're logging into the user, the date command is executed, cal command is executed. Of course, the umask value command also executed, the umask also defined. That is how you can customize your account, right? How it has to be prepared when you logging into the server. Those are the system configuration files that I would like to talk about, which are a hidden files in your home directory. Let me exit again. Let me refresh. When you are actually using the su command to switch to the user. You can use su command or you can use su hyphen pr command, right? Sorry, I need to come out, right? So, right, there are two ways. Su pr and su hyphen pr both are switching to that specific user account only, right? Whenever you give hyphen, that means all the system, all the user properties settings will be loaded. Whenever you are not giving hyphen, that means though you are logging in, but all the system or user specific settings will not be loaded. That is how a small difference between without hyphen, with hyphen. It's always recommended to log in using the hyphen flag. That way, if any customizations that are done to that specific user, all those customizations will be loaded if you are using the hyphen flag. If you are not using the hyphen flag, some customizations will not be loaded and the user will not be having the complete power as per the permissions that are granted, guys. That's how the difference. And it's suggested to use the hyphen flag when you are switching to that specific user. With this, we have understood what is the UMASK value, how the default permissions are affected, and how to set a UMASK value permanently as well as the temporary way. Good. What else? Let me do a simple ls -l. Let me create a one more file, guys. Interesting why I do not have a permission to my home directory. Well, I'm in the same directory. I have the full permission. Let me try to create a file. Yeah, it's done. Well, I created a file. I'm now curious to know when I create a file and I'm understood that how these default permissions are affected. I understood that how the owner is applied there because the currently logged in user who executed a command to create a file will become the owner. I'm worried about this group. Why this group is coming as PR? And of course, that is the default behavior, but I wanted to know more details about this group. Let's say my requirement is when this user is creating a group, sorry, when the user is creating a file, let's say the file has to be created with a group called CLF by default. I don't want PR to be a default group. How do we do the changes? Let's do that. When you run the ID command on this user, we can see this information. The output says PR is the username and whatever the number that you see is called as a user ID. And you can see the groups here. This user is belongs to which groups. Whatever you see in the group section, those are called as a secondary groups, right? So maybe I can create one group and let me add that to that user. As you know, the group creation can be done from the root only. So let me go to the root login and let me run group add and user mod hyphen a hyphen g clf pr user. Let's say group add Linux group user add, sorry, user mod hyphen a the secondary groups Linux group to the PR user. Correct? ID PR. You see now, guys, the PR user is part of three groups. One is PR group, CLF group, Linux group. That means a user can part of multiple groups. All those groups are called as a secondary groups. What is the purpose of me adding it into the multiple groups? So that if any file or directory that is in the PR group, that is in the CLF group, that is in the Linux group, for all those files and directories, I will be eligible to get a group permissions, correct? From technically, If a file or directory is in these groups, because you are part of the same group, you are eligible to get those group permissions. That is what is the advantage of you having the group membership there. We have seen that behavior already. Now I'm interested to understand this GID part. Whatever you see here in the GID part, right? This is called as a primary group. A user can part of multiple secondary groups as and when you need it, but a user can have only one primary group. What is the advantage of the primary group? When this user is creating any file or a directory, that file or directory should be assigned with which group by default, that is decided by the primary group of the user. In this case, because this PR user primary group is PR, the file that is getting created is actually created with a group called PR. If you change the primary group of the user, then yes, definitely the files and the directories that are getting created will come with a different group only, which will be your primary group. Let me do a small change. I'm not trying to add a user to the secondary groups. I wanted to change the primary group of a user. Who can do that? Again, only the root can do the change. User mod, I wanted to modify the user properties. This time I wanted to change the primary group. Hyphen G is the flag to change the primary group. Let's say I wanted to make this CLF as a primary group to the PR user. Done. Let me come back to this PR user. You see now the primary group is changed. Now if this user is creating any file or directory, the file or directory will be assigned with the CLF group by default. As and when these kind of changes are happening, right, in order to take these things into the effect, the user has to log out and log in back, right? Now let me verify. Let me create a file. You see, I'm creating a F10 file, and let me focus on the F10. You see that this file is actually created with a CLF group. Let me create a group directory. mkdir dir12 ls-ld dir12. You see, the directory is actually created with a group called CLF guys. I'm just explaining how this default group will be assigned for a file or directory when you are creating. This group will be the primary group of the user who are actually creating this file and directory. This primary group can be changeable by the root user, and only one group can be a primary group, not multiple groups. That is the importance of the primary and the difference between the primary and the secondary groups in the Linux system. Good. Now I'm really interested on my home directory. I talked about the bash RC, even the bash profile also for the same reason, where we can do the customization, what commands has to be executed automatically, where the custom settings will be loaded. The dot bash underscore history is the file which is storing the history of the commands that you have executed. Ideally, you can run a command called history to see the list of commands that you have executed. You see this list? I have executed a touch command, mkdir id command, right? We can see all the history of previously executed commands by running the history. This is actually pulling this information from a file called bash underscore history. This is the default file that where the details will be but you will be not reading this file directly. Always you need to use the command called history to get that information. And now you can see all the previously executed commands of the currently logged in user is showing here. Now you may be in confusion, right? I'm keep on using L flag, D flag, sometimes A flag. Each flag is actually changing the behavior of the command, what kind of the output has to be displayed here. You may be asking me now, how many different flags are there? Correct? We cannot really remember all these commands and the flags, right? As even when you would like to know more about this command, you take the help of a command called man. Let's say I wanted to know what is this ls command, how and the different flags are available in the ls command. Just use man and the command, hit enter. This is the documentation about the ls command uses and the different options that are there. You see, A is the flag to show all the files, including the files that start with a dot, which are hidden files. Like that, you can see the different flags. Each flag has its own meaning. Obviously, we can't remember all these flags, but try to see at least the important flags that you need to use in regularly. You see, the D flag that I was using to list the directory itself, not their childs, like that. So that is how the man command works, guys. To come out from the man command, just type Q for quit to come back to your bash prompt symbol. Good. So the configuration files that you see in your home directory, these files are applicable to only your account, right? That means, let me come out. When you logging into the account, you see this customization, the UMASK value will be defined. These commands are getting executed. This customization is applicable only to the PR user because the changes are added to the hidden files that are there in the user's home directory. If any other user logging into the account, let's say here I'm showing that the ER user is actually logging into the server. You see, I'm not getting that customization. Why? Those settings are applied only to that specific user in the user's home directory level. Clear? If you are planning to do some customization to which is applicable to the all the users at a system level, right? Then you need to do the change at a file called /etc/profile. /etc/profile is the configuration file where we need to add some profile settings. Whichever the settings that you add here, that will be applicable to all users. What will be in this file? Already some settings are there, some script is there, not a worry. So here I can add any changes. Let's say I want to have 0222 as the UMASK value for all users. If any user logged in, I wanted to run the date command or any other customization like that. If you keep anything in the etc profile, that will be applicable to everyone, guys. Now you see, I'm logging into the AR user. You see, the date command is actually executed. This time, the settings are not done to specific user. I made these changes at a global level, at a system level in the /etc/profile configuration file. Hope we are good with this. Let me clear the screen. So ideally, in the Linux directory structure, slash is the root level directory where all the subtree will be available. Under the slash, we can see there are some standard default folder structure. By now, at least you should be understanding that HOME home is the directory where it has all the users home directories are created, right? etc is the directory where it has all the configuration files. I think so far we have seen etc profile, etc password, etc group, etc sudoers. That is proving that any configuration data that you wanted to customize, those will be available in the etc location. USR is the directory that is holding of all the commands related binary files. We have already seen, right, the command absolute path by running various command. You see, any command, that command absolute binary path is actually located in the USR, right? And OPT is the directory that is where you need to install and configure any third-party specific applications. We will see the OPT later, but OPT is basically to install any custom application that you wanted to. Remember, we talked about that once we are good and familiar with the operating system, then the next step is to install the application, right, based on your business use. So any third-party application that you wanted to configure, we can configure them it in the OPT location. Like that, these folders are having a specific meaning. What kind of the data can be put it into which directory? I'm explaining etc, home, USR, OPT. TMP is the directory which is containing some temporary files. Ideally, the system is doing some work for you, right? It has to generate some temporary files for backend operation. That kind of the temporary data will be get created in the TMP location automatically, and it will be cleaning it up as and when it don't need it. Good. We are trying to understand the folder structure and the use case of each and every directory that persists in your Linux system. Like how you guys will be understanding that in the Windows, what does it mean by the downloads folder, my documents folder, my pictures folder? It's a default, right? Here also we have some folders. We're understanding which type of the data will be in which folders by default. If you go to the var directory, right, var, var directory is mean that to store the files that are vary in size, in the sense this is having some kind of a log data, guys, right? So you can see a folder called log inside that. So all these are the log files that are, storing some data in it. What are these log files? What will be inside the log files? How these log files will help us? We'll see a more detailed look about this var log file location and these log files in the next lecture. I don't want to put so much stuff in one single session, right? So I think that's the story for today. We talked about understanding the directory permissions, how the default permissions are applied using the UMASK value, and how to define the UMASK value as a permanent as well as a temporary, and the primary secondary group differences and changing them, and the configuration files like .bash rc etc profile, and looking into the history of the commands executed by the user, and the use case of the default directories that persist in your root folder, like opt, home, etc, right, tmp, correct, usr. That's the scope for today, guys. If any questions, do let me know, or else we are good for today. So tomorrow when we are regrouping here, we will be discussing about the log section, the different log files that are available. Then we will proceed further in discussing about the other concepts. Thank you.